Okay, so this is day 2 of parent functions. We are going to be talking about 4 specific parent functions. And those parent functions are going to be cubic, absolute value, rational, cubic, and cube root. So actually, I'm going to start with the absolute value. That's the order of the slide. All right, so the equation for absolute value is y is equal to the absolute value of x. So you got these like vertical lines that are surrounding the x. And the graph of an absolute value is always going to be V-shaped. So that's how you know you're dealing with absolute value. Okay, put arrows at the end. And then we're just going to work through those attributes like we did on day 1. So domain, if I go to the left and then go to the right, I'm going through arrows, continuous. So that's negative infinity to positive infinity. And we're going to add set builder notation so you guys can be aware of that. So x such that x is an element of all real numbers. So that's what, anytime you go from negative infinity to positive infinity, you are describing every real number possible. All right, range is low to high. So if I go low, I start at 0. If I go high, I'm going to infinity. Okay, set builder notation would be y such that y has to be greater than or equal to 0. So if I'm between 0 and infinity, I'm greater than or equal to 0. Checking where it crosses the x-axis. So it crosses the x-axis at 0, 0. Cross the y-axis at 0, 0. Okay, I have asymptotes at, I'm looking at my graph and I'm looking at the graph does not have any jumps. It does not have any breaks or discontinuities or holes. So therefore, does not have asymptotes. If you look at the max, it continues on forever. So there isn't a max. Minimum, the lowest the graph is going to ever get for the parent function, it's going to be at 0, 0. And if you look at the graph, it is reflectional about the y-axis. And then this function does not have an inverse. D and E means does not exist. All right, moving on to rationals. So the rationals, for rationals, our equation for rational is going to be y equals 1 over x. So rational is like what it seems like. Rational numbers are fractions. So a rational equation is kind of set up like a fraction. If you look at the graph, to me they look like two like boomerangs, like the little things that you throw. You throw and bring back to you, but the proper name for it is a hyperbola. So these are hyperbolas. That's the description of the graph, or the proper name for the graph. The domain, if I'm looking at the domain, if I go to the left, I'm at negative infinity. But when I get to the right, it stops at 0. So negative infinity to 0. And then it jumps. So that lets me know that there's a jump there. That lets me know there's going to be an asymptote involved. Then it jumps and come here and continue from 0 to positive infinity. So we're going to union that. Okay. Since we were on asymptotes because of the jump, we're going to go ahead and write that. It has a vertical asymptote at x is equal to 0. All right, if you're looking at the range, if I go low to high, there's another break in the graph. Low to high, negative infinity to 0. approaches zero or the x-axis, but don't touch. Then it comes back from zero to positive infinity. Another jump, which tells me there is another asymptote, and that asymptote is a horizontal asymptote that y is equal to 0. Okay, x-intercepts. If you notice, it does not touch the x-axis. It approaches because of the asymptote, but don't touch. So there is no x-intercepts, as well as it approach the y-axis, it gets close to it, but don't touch. So therefore, there isn't any y-intercepts. So those do not exist as well. And we're talking about the parent. Okay. For maximum, as it goes on this end, the highest part is continuous, so there is no maximum. The lowest that the graph is going to get, it continues, doesn't stop, so there is no minimum. Okay, and then when we talk about symmetry, this has it's not going through the origin, so therefore, let's see, I'll do this upside down. See how that graph doesn't change? It still looks the same. So this has rotational symmetry, and the inverse does not exist. So that's rational. Cubic. The parent function for cubic is y is equal to x to the third power. It's the graph. It looks like a little snake to me. Again, this does not have a mathematical name for it, so you can associate it as you will. But if I'm going from the domain, if I go to the left, I'm going through arrows, right arrows, so that's negative infinity to positive infinity, or x is x such that x is all real numbers if we're doing set notation. Range, if I go low and high, I'm both continuing forever. Low, high arrows, negative infinity to infinity. And set notation will be y such that y is also all real numbers. Touch the x-axis at the origin, so therefore your x-intercept and your y-intercept are both going to be at 0, 0. There's no jumps, no holes, no closed circles. So therefore there isn't an asymptote. So it does not exist. The maximum, if I go to the high, it continues, so there is no maximum. If you go to the low side, it continues forever, so no minimum. And then this has rotational symmetry. So again, when I turn the paper upside down, it looks like the original graph. So that's how you determine rotational symmetry. Okay, and the inverse of a cubic is a cube root. It's a little 3 as an index right there with a square root sign. How you write cube root. All right, the last function, parent function for today is cube root, which is written as such. The graph looks like a horizontal kind of S shape or snake kind of shape. So if you look at it, it looks very similar to this. This is going more vertical. This is going more horizontally, kind of like your square root, but there's 2 parts. So the domain, negative infinity to positive infinity, or if we were in set notation, x such that x is all real numbers, your range is going to be, if you go low, it's still going to negative infinity. If you go high, still going through arrows, positive infinity. So your range is going to be y such that y is all real numbers. Okay, looking at the intercepts, where does it touch the x and y axis? It's touching at the origin, so therefore your x and y intercepts are going to both be at 0, 0. If I look at the graph, again, there's no jumps, no holes, no curves that are parts of the graph that are leveling out, so therefore there isn't a asymptote or does not exist. The maximum, so if you look at the top, this is continuing, so there isn't a maximum. Does not exist. If you look at the minimum, you look at the bottom, doesn't stop, does not exist. And your symmetry, again, is rotational. So if I take this graph or my paper and turn it upside down, again, that looks like the original graph in the original way that it started. So therefore, I'm dealing with rotational symmetry. And then last, your inverse is going to be a cube. So the reverse or inverse of a cube root is going to be a cube. Okay, and these are all the attributes of the day 2 parent functions, which again is absolute value, rational, cubic, and cube root. So hopefully that helped you out. Let me know if you need anything.